This episode of the APWA Roving Reporter took us to South Bend, Indiana, where we're going to look at their smart sewers technologies. We're joined by Luis in front of the mock-up of what is in the streets here in South Bend, Indiana. And Luis, you want to tell us a little bit about yourself and a little bit about Xylem?
Yes, absolutely. My name is Luis Montestruque. I'm a senior advisor for Xylem. Our story here with South Bend started about 17 years ago. We were a startup called Mnet that developed a system utilizing Internet of Things and machine learning to help manage combined sewer overflows. During intense storm events, the combined sewer system can get overwhelmed and cause overflows to the St. Joseph River through a three-step process and a framework that we call the real-time decision support system.
Okay, why was this concept right for South Bend?
I think that when we started with South Bend, the first portion of the work that we did was installing this monitoring system. And we realized that storms don't actually affect the entire city all at the same time. There are storms affect different parts of city at different times. And so what we saw was that when some areas were overwhelmed, there were some areas that were not. And so the idea was, how can we utilize technology to maximize the utilization of this system and avoid overflows?
Data collected from the sensors has saved over $500 million. What is the data saying, and how is it saving money?
So the data is used in real time to monitor how the sewer system is behaving. Where is it that we lack hydraulic capacity, and where do we have excess of hydraulic capacity? And so the sensor system helps the city understand where is it that water can be redirected to avoid overflows. And by doing that, it reduces the need to, let's say, utilize a tank or a tunnel to store the water during those rain events. So the size of all of that infrastructure can be reduced or can be reapplied to, let's say, green infrastructure and help the city avoid those costs.
You gave us a brief history back to 2004, 2008. How was the project funded, starting all the way back in the mid to early 2000s?
So the initial funding from for the project, when it was on research and development, came from the Indiana 21st Century Technology Fund. It was a research grant, and those funds were initially able to pay for the demonstration of the technology and the pilot. And then later on, the monitoring and the subsequent installation of the valves was a combination of just regular capital provided by the city and some additional grants that were available at that point in time, the American Recovery Act funds.
I'm now joined by Eric with the city of South Bend. Eric, the new smart sewer system has prevented over 1 billion gallons of raw sewage from entering the St. Joseph's River here in South Bend. Tell us why that's important.
Yeah, so the Clean Water Act was set up so that we could reduce the pollution going to the river. So what happened was, during normal conditions when there wasn't any rain, the system could handle all that flow and could get to the plant and be treated. But when it rained, it would create a lot more flow, and it was too much flow to get through the pipes, but also to the treatment plant itself. And so what would happen is, at that time, then it would overflow to the river. So instead, what we're doing is trying to minimize the amount of that overflow that goes to the river by being smart about what we're doing and creating a system that can capture that and get as much to the treatment plant as possible, so that a lot of that sewage does not go to the river any longer.
Earlier, Luis mentioned that there is kind of 2 or 3 phases to the project, going way back to the early 2000s. Can you take us through those again, and what was involved in all those phases?
Sure, absolutely. So I think the first thing is, cities a lot of times don't really have a good understanding of what's going on down in the ground in their sewer system. And so a lot of times I'll use an analogy of our road system as a similar system, right? It's moving cars instead of sewage, but you can clearly see where you've got congestion and where you've got roads without any traffic. And so in those cases, if you know you've got a road that's got a huge traffic jam and roads that don't have any cars, you can either build a bunch of new infrastructure for that road with the traffic jam, or you can try to divert some of that traffic to those roads without the jam. And so we did the exact same thing here. We tried to understand what that system was doing in the ground, and the sensors gave us that ability. So that was phase one. The second phase then is using that information to help us be better stewards, and that was trying to, again, instead of building additional lanes, let's move the traffic to something that already exists. So we've got this interceptor, and we now understand that we have some capacity in it because of the sensors are telling us that. So we had to create a system that really understood how much room is in that interceptor, try to use it to its fullest capacity without overusing it. And then the third phase was, as we looked at our long-term control plan, that we were going to build $700 million worth of capital infrastructure. We started really looking into what could we do instead of big tanks, to use this smart system that we had to try to make sure that we got as much flow through as little dollars possible. And in order to do that, we had to understand the system better. And so created a model using artificial intelligence that was based on all these millions of data points that we were getting every year to inform the model. And so then by the time we built the model and understood the system better, we actually found ways to divert that flow. So now we don't need to build a tank at all at Lever Park. And so we were able to save tens of millions of dollars just by understanding the system better.
Seen the sensors in the actual sewer. Now we're going to look at what the employees at South Bend are seeing, what you're seeing, Luis, when you're looking at the data being collected by the sensors. Can you kind of take us through what these screens are showing you here?
Absolutely. So what we have here is a system that helps the city understand what are the sensors measuring in real time. We have a map here that the city can hover over any particular point and understand levels and flows that each of the different sensors are indicating on the system. And they can actually also see trends, for example, when we have an overflow happening or when we have a particular rain event, to see how the sewers are carrying that water. And then here we have what is called a hydraulic profile view of the sewer interceptor line. And so you can see here a sort of a section cut of that sewer line that runs from the southern part of the city and takes the water to the treatment plant. In this screen, you can actually see the different levels as measured by the different sensors. So this helps the city have a comprehensive view of many sensors, all of them in context, so that we can understand, for example, when we have a surcharge system, like in this particular instance, where we have sections of this interceptor line that are shown as surcharging.
I'm joined by Kieran with the city of South Bend, Indiana. And Kieran, we want to talk now about kind of what led up to the Smart Sewers projects. What did the Clean Water Act play? What role did the Clean Water Act play in this project?
Okay, so the Clean Water Act from the early 70s is vital to obviously keeping water clean, hence the name. But in 1994, the EPA had the CSO policy, the Combined Sewer Overflow Policy, that meant that cities were to change the way in which they manage combined sewers, and that became part of the Clean Water Act. So basically, the Clean Water Act, compliance with that and enforcement of our compliance with that by the federal government meant that we had to do all this work.
So let's look to the future. Look towards 10 years, 15 years, 20 years in the future. What's next?
Well, first of all, we've been lucky. I know engineer or scientist likes to talk about being lucky, but generally we have in the success that we've had, because we've always been very cautious and conservative about the approaches. We'd say, we're going to go down this route, something kind of novel, and a lot of the stuff that's happened in South Bend has been novel and it has been new. So there's nobody really to gauge it against. You can't say, well, such a city had this success, because we were kind of one of the first to do that. But everything we've done has been more successful than we've anticipated. So we're at that stage now where we could cautiously hope that we'll have more success like that. While our new long-term control plan is still being cautious, we're also quietly hopeful that it'll be, we'll be able to do even more than what we've planned to do. But also, over the last couple of years, the success that we've had have been able to make us think that we should be able to do more outside of just the sewer system, because obviously the sewer system is the collection system, but there's also the wastewater treatment plant as well. So we're hopeful that we'll be able to in the future roll into wastewater treatment and be able to do more of a kind of a smart sewer technology approach within the grounds of the wastewater treatment plant. So being able to do more with smarter automation and digital twins and modelling and that kind of stuff as well. And that's something we're just really on the cusp of at the moment in South Bend, and working with Luis and his team at AIMNet and Xylem to do that. And that's something that'll happen over the next year or two. Because the long-term control plan, which is the $276 million project, a large proportion of that is an expansion of the treatment plant up to 100 million gallons from 77 as it is today. So we're hopeful that as those developments change, as we increase the capacity of the treatment plant, we'll be able to do more smart technology up there as well, and continue the success that we've had in the field, but within the confines of the treatment plant.
That wraps it up from here in South Bend, Indiana. I want to thank Eric Horvath, Kieran Fahey, and Luis Montestruque for letting us see their operation here. If you want us to come out and look at your public works project or your special achievement in public works, let us know. Connect to us through social media, email, or phone call.